So this question looks quite complicated when we first look at it, but really it's no different to any of the other questions that we have been doing. So what we know is that in a factory there are three machines, J, K, and L. So those are our first choices in our first branch. So if we start with our point here, so we have machine J, we have machine K, and we have machine L. So those are our first choices. And we know these machines make biscuits, but they do break them as well, but they make them. And so the second branches are going to be whether the biscuit is broken or not broken. So if we have broken, not broken, broken, not broken, broken, and not broken. So that's our first and that's our second option that we can make our combination of outcomes from. So in some respects, it's a bit like tossing a coin and rolling a dice. We have two different things producing different outcomes. Now we know that machine J makes 25% of the biscuits. Now I think it is simpler to convert that into decimals. You can leave it as percentages if you want to. You will get the same answer, but I'm going to make that into a decimal. So we know that the probability, well, we know that J makes 25% of the biscuits. And we know that K makes 45%. So again, if we make that into a decimal, it's 0.45. And it doesn't tell us how many biscuits are made by L. It just says the rest of the biscuits are made by L. So we know that our branches should add up to 1. So if we add 0.25 to 0.45, then we get 0.7. And then if we take that away from 1, that will give us the remaining branch. So that's 0.30. So you see how all the rules regarding probability and it all adding up to 1 and knowing when it's not something you can take it away from 1. So we needed to work out the remainder. So we added these together and took the answer away from 1 to find the answer. Now we know also that 2% of the biscuits made by machine J are broken. So 2% of these biscuits are broken. And we know that 3% of the biscuits made by machine K are broken. So that's 3% there. And we know that 5% of the biscuits made by machine L are broken. Okay. Now, because we've got the first part of each of these branches, we can again use this rule of the branches adding up to 1 to work out what this would be. So 1 minus 0.02 is 0.98. 1 minus 0.03 is 0.97. And 1 minus 0.05 is 0.95. Now we have all the bits we need in our tree to work out the probabilities. Now if we have a look at the outcomes, so if we follow this branch along, so the probability of picking machine J and, remember the and sign, the intersection, the probability of picking machine J and the biscuit being broken, well, we times along our branches, and that equals 0.005, and that comes from 0.25 times 0.02. Okay, so we've just times along this branch here. So what about the probability that we pick machine J and the biscuit is not broken? So the probability we pick machine J and the biscuit is not broken. Remember that little sort of apostrophe sign for not, so not belonging to group B? Well, that is 0.245, and the way we get this is 0.25 times 0.98, sorry, times 0.98. So we're following this branch along here. And the same with K. So what's the probability we pick machine K and the biscuit is broken? Pick machine K and the biscuit is broken. Well, that equals 0.0135, getting quite small numbers here. And that's because it's 0.5 times 0.03. 0.45 times 0.03. And that's how we get this answer here. And what about if we pick machine K and the biscuit is not broken? So machine K and the biscuit is not broken. And that equals 0.4365 because we're timesing 0.45 by 0.97. And so on, and we can fill in the rest of the outcomes and the probabilities. Okay, so we've completed our first part and we've drawn the tree diagram. We've illustrated all the possible outcomes and we've also listed the appropriate probabilities. So now it asks us that a biscuit is selected at random. Calculate the probability that the biscuit is made by machine J and is not broken. So we want machine J and it is not broken. So machine J, so the probability it's from machine J and it's not broken. Not broken. So that equals 0.25, the machine J, and it's not broken, and it's times in because we're going along the branches, and that equals 0.245. Okay, so machine J, and it's not broken, and we times along the branches. Now the next question is slightly more complicated. So we need to find the probability that the biscuit is broken. Now you can do this one of two ways. Now we've already written down here the probability that you pick a certain machine and the biscuit is broken. So if you pick machine J and the biscuit is broken, if you pick machine K and the biscuit is broken, and if you pick machine L and the biscuit is broken. So we know when we're going down the leaves, you add the probabilities together. So we can simply add the probability of each machine together. So that would give us 0.005, add 0.0135, add 0.015, and that equals 0.0335. Now I think that is the simplest way of doing it, but that relies on the fact that you've already listed out your probabilities at the beginning, but that is what the question did ask us to do. So if you hadn't already done that, all you would need to do is calculate along the branches like we did to work this out. So 0.25 times 0.02, add 0.45 times 0.03, and then add 0.30 times 0.05. So all you're doing is going along the branches like we did initially to work out the probabilities and then adding them together. So that would still give you the answer 0.0335.